Okay, first topic for today is probabilistic sampling. Um, it basically is the Cadillac version of sampling. Um, just to kind of bring together the 2 weeks, the last week when we did item validity, now we're doing sampling methods. What we did last week was internal validity. So, how well constructed are your survey items, and are you measuring what you want to measure? With external validity, what we're looking at is when you get your results, do they generalize to the population of interest, right? So you get your results. Can you say this? Can you make the statements about what you found and say that they are representative of what's going on in my target population? So that's the focus of today. The Cadillac of sampling, like the top end is basically, it's not even sampling. You basically have the whole population, right? So you are sampling, but it's not like how we think of it. What it is you have everybody, and it's very expensive, but it's very important. And as the quote says here, census of population is fundamental to any country's statistical infrastructure. In Canada, the census is currently the only data source that provides high quality population and dwelling counts based on common standards and at low levels of geography, as well as consistent and comparable information on various population groups. And the 2016 census cost roughly $47 per household to run, so it's not cheap. And the upcoming one there's one in 2016, and I guess every 5 years there'll be one in 2021. How is the census used? It's used to set electoral boundaries to ensure that we have appropriate representation across the different regions of the country. It's used for service planning, so for infrastructure, for education, health, transportation. It's used by the census data is used by private sector businesses. So for corporations and companies, in terms of their medium to long-term business planning, in terms of growing their business, where if they're building factories, where do they have to build those factories? The census data is used by insurance companies for actuarial as a form of actuarial data to assess insurance risk and the setting of insurance policies. And it's used by agriculture, agribusiness, in terms of food production and distribution. Also used in academic research, right? And there's two forms of the census. There's the short form, which collects all of the key information, and then the longer form that goes into greater detail about a person's life. So, for example, the short form may not collect information on education, but the long form may collect information on education for, say, the individuals within a household. Okay. So probability sampling is when you have basically access to a population. So you know the population is clearly defined, and then you randomly sample from within that population, right? So used by big government, we use by polling firms. So when you have access to the whole population, you can assess. It's really important in terms of use random sampling that you're able to determine what's the probability of each member of the population being selected for your survey or study. And we'll talk about just simple forms. There's simple random sampling. We'll talk about cluster sampling. And then we'll talk about stratified sampling. So I'll just give 3 examples in terms of how we can sample from a known population where we have access to each individual within a given population. Okay. The survey frame, in terms of a term, is called the sampling frame when applied to sample surveys. This provides your means of identifying and contacting the units of the survey population, right? So how do you get the contact information for all of the individuals within a population, right? So you can get it from vital statistics registries in terms of births, deaths. You can get it from business registries if you're looking at it from a commercial side. Household information from, say, from the municipal level, for which is households are used for taxation purposes. Telephone directories. Before cell phones, if you were doing sampling and you were doing household sampling before the cell phone, you could buy, say, from Bell Canada, all of the residential cell phone residential landline numbers for, say, the province, and it would give you the landline number for the household and yeah, and then you could call that, if you're doing household level information, you can then randomly call those numbers. Customer client list for companies, right? If the population is existing customers, then you can sample from that. And organizations membership lists, right? So for example, we've run MRPs with organizations for like the Barrie Chamber of Commerce. Well, we can randomly sample from the membership lists. If your target population is existing members of the organization and you're looking at member engagement, then yes, you have that information. That's your survey frame. Okay, simplest form is you randomly sample from within your sampling frame, from within using your sampling frame. So if it's members of the Barrie Chamber of Commerce, and you're not going to sample the whole membership, let's say it's just fairly large, you can then randomly sample. And next week we'll talk about, well, how do you determine your sample size? Okay, and that's easy to do. Most software, most programs have random number generators. So if I can just get rid of this here. So if I have I'll sort here, custom sort by person. Okay, so this is person. Let's say it's a member. And let's say I want to randomly sample a subset of this population. Well, every product has a random number generator, right? So in Excels are relatively crude. There's more advanced one in SPSS and software that's more driven by that. It just produces a random number between 0 and 1. Now, the key thing is this is dynamic, right? Random numbers generators typically need a seed. So I can, I'm not sure if I can seed random numbers. Let's put 0.1. No. Usually sometimes you can seed them, so let's not do that here. Okay, but the key thing is it's actually dynamic. So if I go in here and change, or the numbers will always change, right? So it's tied, usually they're tied to the internal clock in the computer. So you can see how that's always changing. But what I can do is, with my random number generators, I can sort. Right, so I can do a custom sort. I didn't need to highlight that. So if I sort by a random number from smallest to largest, it'll sort them. So now I can just, if I want, pick the top 5 members. Now you can see how it's actually changed. So it sorted it and then changed it. So, but I do have a random sort here from when from when I ran the sort and then it updated. So I can pick the top 5, or I can just randomly sort it and then pick every 4th member, right? So that's just simple random selection. And all programs have random number generators. I can show you in SPSS how to, like, you can have random generators that are uniform, equal probability between 0 and 1. I can have random number generators that are normally distributed. I often use it for my fake questions. Okay. So the pure thing for pure random sampling, EPSOM is the important thing, equal probability of selection method, right? So if I'm randomly sampling from a population, every member of that population should have an equal probability of being selected for my study. And if I'm using a random number generator, I've basically have met that criteria. Okay. And this is just walking through what I just did with the random number generator. I can select the first 5, or I can select in this case, every 5th element from my random list, right? So you can use random sampling. You can use Excel to do it, to random sample from a given population, your sample frame. If you get a list of all the members from, say, the Barrie Chamber of Commerce, and you only want, of the 400 members, you only want a sample of 100, then you can just use a random number generator to select or sort by the order of the smallest to largest for the random number. So it's relatively straightforward. Okay, you can, and once you do, when you have the population, you can then use more effective, cost-effective methods for sampling. So one thing is a single-stage cluster sample. So what you can do is you can break your population into clusters. And the clusters should be relatively homogeneous. So I'll use the example I'm going to use is the high schools within a school board, right? So I can use the high schools. High schools should be relatively similar in terms of their makeup, but within high schools, each high school will touch, so for example, different neighborhoods, and the neighborhoods will differ in SES, like socioeconomic status. So there'll be heterogeneity within each cluster, each school, high school, but the high schools themselves are relatively similar. It's a very cost-effective way. What I can do is I just randomly select a cluster, and then I sample within each cluster, right? So what makes it cost-effective is if I randomly select, if I use my example, if I randomly select high school students across the board, I'm going to be running all over the place to get those individuals. With a single cluster sample, I randomly select the high schools. And then I go within the high school and just survey all the kids within the high school, right? That's my secondary sampling unit. It's a much more cost-effective way in terms of I don't have to run around as much, right? So it's just more cost-effective to use like this form of a single-stage cluster sampling. Key thing is, the high schools are, when I compare one high school to the next, they're relatively homogeneous, but within each high school, there's a fair amount of heterogeneity, right? The high school students differ in their makeup. They come from different neighborhoods, and all the high schools touch upon the wealthier and poorer areas, for example, of the community. But the key thing is, with single-stage cluster sampling, once I've picked my high school, I sample all the kids from within the high school. I can use two-stage cluster sampling, where I have my high schools, and then I form a subset of students, and then I randomly select within my subsets, right? So, for example, I randomly select my high schools, and then I go into the high school and I randomly select students from within the high school. So I can pick more clusters if I want to, and then randomly select within each of the clusters, as opposed to a single stage where I randomly select the clusters and then I pick everybody within the high school. So all the students within the high schools I randomly select are picked. I can use set two stage where I may say, okay, I'm going to randomly select more high schools, but I'm then going to randomly select within each high school just to save my costs down. And you might do that if you're kind of concerned about the homogeneity in terms of how similar the high schools are. So you may include more high schools in terms of your randomly selecting your clusters and then randomly select within them. Okay. You can use what's referred to as multi-stage cluster sampling. So I can say, okay, I randomly select the high schools within the city, and then within the high schools I've selected, I then I break it down. My next level of cluster is each of the grades, 9 through 12, and I may have 3 or 4 classes or groups within my grade, right? So I got like my different classes in grade 9. I then randomly select the classes within each of those grades, right? So I'm using a multi-stage cluster sampling. Randomly select high schools. Then I select the grades within each high school, which is the second level of my cluster, and then I randomly select students within each of the grades. Okay. The next thing, a different type of, which is a variation of cluster sampling, really, is stratified sampling. With cluster sampling, you're creating your clusters, and then you're randomly selecting clusters. With stratified sampling, that first layer, you're not randomly selecting, right? So it may be tied to your how you've grouped at the higher level may mean that they're more heterogeneous, or there may be greater, they may be very different. So what then will happen is, so for example, the best example is Strato in terms of, say, for Stats Canada wanting to sample, or let's say you want to sample within the nation. And you know that there's a population breakdown, right? Ontario is different than PEI, which is different than Quebec. And they differ in population, right? Ontario being the most populous province, PEI probably being the least populous province. You're spending money, you want a good sample across the nation. You want a representative sample of opinion of Canadians. Well, if you're random sampling, you may end up disproportionately sampling one region or province over another. So for a stratified quota sampling, you say, okay, I'm going to break the country into the provinces, geographic areas, and then I'm going to use a quota system, and I'm going to sample within each province, right? So I want a representative. If Ontario makes up 10%, 12% of the population of the country, I want my sample to be 12% of the people from Ontario, right? So then you have a quota system. So for example, using the high school example, you stratify by grades, right? You stratify by all of the high school students in grades 9 through 12, right? And let's say that proportion. Let's say they're equal proportion, grade 9 through 12. Then what you do is you say, okay, if I've got what 9, 10, 11, 12, I got 4 grades. If I want to sample 1,000 students, I'm going to make sure that I randomly sample 250 from grade 9, 250 from grade 10, 250 from grade 11, and 250 from grade 12. That'll give me a representative sample, and I'm stratifying by grade. Now it's a bit more expensive because I'm going to take all the students in the whole school board from grades 9 through 12 and do randomly sample quota based within each of the grades, right? So you're getting a sense that when you have access to the population and you can contact them, you can do fairly sophisticated sampling.